Let's move to part 3 now. Same again, continuing with the same section, introduction. In the last video, we recollected formula for area of rectangles L into B and the basic formula for area of triangles half B into H and proved both. You may be wondering why I am telling basic formula, because any triangle half BH is sufficient, but certain conditions we will not be able to find the area with half BH. We will see in this part what is the issue. So we are going to check whether we can use the basic formula for area of triangles for different types of triangles. Area of a right angle triangle. I will be going a little fast because these are all very simple proofs, simple sums. So a triangle is given where I will write this thing. Triangle ABC, 3 sides are given and C is the right angle. So see diagram 1. We have to find the area of the triangle. So for better understanding, let us rotate the triangle such that CA is at the bottom. Let's see. Yes, now I have rotated the triangle. So let us mark A, B, C. CA is at the bottom. Let me put the 90 degrees. All I have put. Now you can see it's a right angled triangle. You can easily make out from this. CB is the height. Let us see what is that in the next point. Yeah, this is number 2. Here CA is the base and CB is the height. So we will be learning more about height in the later part, why it is called a height and what is the definition of height. But for the time being, you can see I can explain the perpendicular line from the base to the opposite vertex is the height. So here base is CA and the perpendicular line CB. CB is the height of the triangle. So this we have now rotated. Let us move to the next page. The same two diagrams. So we can also rotate the triangle such that BC is at the bottom. That is, now we saw CA as the bottom. So CA is the base and CB is the height. I am going to rotate in another direction where now we have got A, B, C. I will put all the dimensions and the 90 degrees at C. So now what happened? BC is the base and CA is the height. So both are possible. So we will see when we see the formula next page, you will be able to understand further. But for now you can note down all the 3 in your notebook so that you will be able to understand which we are going to follow. We will move to the next page. So in a right angle triangle, the sides other than hypotenuse are known as legs. Therefore, area of triangle equal to half into B into H equal to half into L1 and L2. So you can see the purple alphabets, which I will explain when we go to the end, where L1 and L2 are the 2 legs of the triangle. So it can be either the triangle opposite we can say on 2 sides of the on the 90 degrees, we can call anyone as L1, anyone as L2. So it can be used interchangeably. Since any leg can be considered as base or height, as I have written here, as shown in diagrams 2 and 3. So in 2 we saw BC as whatever, I don't remember, BC as the base and the other one we saw CA as the base. So we can consider any one as the base, any one as the height. That is the side which is not the hypotenuse, right? These are the 2 sides or 2 legs. Any one leg can be considered as base and the other one as height and vice versa. Formula for area of right angled triangle equal to half into product of sides other than hypotenuse. Product means multiplication, you know. So you multiply the 2 sides and halve it, that is divide by 2, you will get the formula for, we will get the area of the right angled triangle. So we will see the practical example also in the next page. So area of, in this page itself, sorry, area of triangle ABC. Now we have been given one side as, one leg as 5, one leg as 12, that is hypotenuse is 13. We cannot take hypotenuse. We can take any 2 legs. So multiplication half into 5 into 12 is 30 centimeter square. It can be half into 12 into 5 also. So that means both the legs can be interchangeably used. So the formula for right angle triangle is half into product of sides other than hypotenuse. We will go to the next page. So very easily we have proved this sum. We have solved the sum. So hence formula area equal to half into BH can be used for right angled triangle. So this is possible. Since we are verifying for each different type of triangles, so this right angled triangle, it is possible. So see a note here, unit of measurement is very important. you can see, since the area is calculated by multiplying b centimeter into h centimeter, half into b into h, correct? B is centimeter, h is centimeter. The answer will be b into h centimeter into centimeter equal to bh centimeter square. So the unit of measurement is to be clearly mentioned, otherwise you may not get full marks in the test. Now we will go to the next one. So we are going to see an equilateral triangle now. Here 3 sides are given 10 centimeter. We have to find the area of the triangle. So from base we will explain why it is required. So we are drawing a perpendicular line to opposite vertex P. So this is 90 degrees on both sides and we'll name it as M. Therefore MP is the height. Now as I told in the last right angle triangle, a perpendicular line from the base to the opposite vertex is called height. But here their height was given because one of the legs is height, we can consider as height. Here we don't know what is the length of PM as well as how far is PM and M is from Q and R, right? So we are going to do this using congruence of triangles. Now you see the importance of congruence of triangles. I am not going to explain the congruence of triangles. You can yourself see. I have not put any angle, everything. All are very simple. I am putting all the angle symbol only. Yes. So this is an SAS congruence rule. Because of this, what happens? This QMP and RMP are congruent, and because of this QM equal to RM equal to 10 divided by 2 equal to 5 centimeters CPCT. So this is very simple. If you don't understand, pause the video, thoroughly check, learn and then move to the next page. We'll go to the next page. It's okay. I have put 5 also. So here what I am going to do, we know the location of M with reference to Q and R. Now we know QM equal to MR equal to half A. So I will mark that A, half A. Now I am removing the values and I am putting A and H, so that we are going to prove find a formula for area of an equilateral triangle. So this is in triangle QMP, we are using Pythagoras theorem, a square equal to h square plus half a square, or h square equal to a square minus a by 2 whole square. Half a square and a by 2 are same. So these formulas are all very clear. I am just converting everything. Now here I am converting h to taking the root that side, root 3 a square by 4, taking a square by 4 equal to a by 2 outside the root, a by 2 root 3, that is a height. Now base B of triangle QMP is nothing but A, that is half A plus half A is A, that is one side of the equilateral triangle. Therefore, area of triangle QMP equal to half B into H, here base B equal to A and H equal to A by 2 root 3. So what happens? Half into A by 2 root 3 is A into A square, 1 by 2 into 1 by 2, 1 by 4 square. So it has become A square by 4 root 3. Again, it's all very simple. You can just pause the video and understand each and every point. If you have doubt, you can write in your notebook in the way you understand. Even step number 3 can be further broken into different steps, and then you can write in your notebook. Now we have found out the area. Let us go to the formula block I have put a square rectangle and put that. Let's see in the next page. So this is the formula for area of equilateral triangle, a square by 4 root 3, where a is the side of the triangle. So if you know one side of the triangle, then you can find the area of the triangle using area of equilateral triangle using half BH formula. Therefore, okay, here I am using the form that we have given the values, right? Triangle PQR, a square by 4 root 3, a is 10, 100, it's all very simple calculation. Answer is 25 root 3 centimeter square. So hence formula area equal to A half into B into H can be used for equilateral triangles. We will move to the next page. Now we are going to see isosceles triangle. Here we cannot use any separate formula, we will use only half BH, but I will go a little fast because the same type of proof, 5, 5, 8, the same we are going to do. Perpendicular, I have drawn the height, but we don't know the location of P with reference to Y and Z, or we don't know X, P length. So we are using the same congruence rule. So these two triangles are congruent. We'll go to the next page. Just for immediate reference, for your easy reference, I will mark which two triangles. So this and this, these two are congruent. So because of this, what happens? YP equal to, yp equal to pz, zp 4 centimeters. So now we have got, now we know what is yp. From this we are going to use Pythagoras theorem again. So these are all simple rules. I have put the values itself here because there is no separate formula. So phi square equal to 4 square plus the xp square, which xp we don't know, or px. So px equal to root 9 equal to 3. So we have got it. We are using this in the, now I put the root 3 also. Area of triangle xyz equal to half bh 12 centimeter square. Hence we can use this formula for isosceles triangles also. So now we have seen we can use it for right angled triangle, equilateral triangle and isosceles triangles. Then what else left out? Think about it. Yes, most of you would have got it. You are going to see a scalene triangle. What is a scalene triangle? Where the length of all the three sides are different. No side is equal to the other side, or none of the angles is 90 degrees. So here three sides are given 11, 9, 7. We have to find the area of the triangle. From base B, again we do the same thing. We are drawing the height. So we have to now find out how far is D from A, as we did in isosceles and equilateral triangle. Therefore DC, but we don't know what is the length, right? Since all the sides are of different lengths, as well as none of the angles is a right angle, we cannot use any known theorems. So here we are not able to proceed further. We are not able to use any congruence rules. We don't know, we cannot use that right angle, or we cannot use Pythagoras theorem. So what to do? Let's go to the next page and see what we will do. However, there is a formula which we will see in the next part for finding the area of triangle without knowing the height. Hence, formula area equal to half into b into h cannot be used for scalene triangles unless we know the height of the triangle. Suppose you know CD, then we can straight away find, right? Because we can apply half into CD, whatever measurement is given, into 11, we will get the area. But here h is not known, and we don't know AD also, or DB. We are not able to use Pythagoras theorem also. So which we are going to see a new formula in the next part. So in this part, we have checked whether we can use basic formula for area of triangles. We found it is possible for right angle, equilateral and isosceles, but not possible for scalene triangles unless we know the height of the triangle. And we also learned a formula for right angle triangle, which is nothing but half into product of sides other than hypotenuse, and for equilateral triangle a square by 4 into root 3. In the next part, we are going to learn a formula to find area of any triangle given its sides only, and verify this for the areas of different types of triangles discussed in this part. Some questions now. 3 questions in this page. Pause the video and then move to the next page. We'll see next page. 2 more questions. Pause the video, note down all the questions, and then after understanding thoroughly the video, attempt the questions. That's all for this video. Thank you.